we're starting to build up to getting into reactions of substituted alkanes. And before we can really do so, we have to think about um, how to uh, how to solubilize them in different solvents. And we've already seen that solvents can play a critical role in the physical properties of substituted alkanes. So, for example, we saw that solvent affects the acidity of alcohols because of the stabilizing effect of their conjugate bases. We also saw that solvents affect the basicity of amines due to the ability to stabilize the conjugate acid of those amines. So it's important to take a moment to think about what solvents are going to solubilize the various alkane derivatives, right? And in general, polar solvents are what we're going to be looking at. Now, there are a variety of polar solvents, and one of the things that we have to understand is the classification of polar solvents. So, polar solvents are classified as either protic or aprotic. And these are new terminology that you need to really understand in order to really to comprehend how solvents are affecting different things. So keep in mind, we're going to be focusing mainly on polar solvents for in terms of the solvent medium of a lot of our reactions that we're going to be looking at. Um, and we have to understand the difference in that classification. So a protic solvent is simply a solvent that can donate a proton. And if it can donate a proton, it can form hydrogen bonding, right? So this is important. Protic solvents, alcohols, water are protic solvents. And then we have aprotic solvents. Aprotic solvents simply do not have an available hydrogen to form hydrogen bonding. So we can have a polar solvent that doesn't um, that cannot form hydrogen bonding. That's called an aprotic solvent. And if you look here at the table 6.10, you see some various polar solvents. So water is a polar solvent, formic acid, methanol, ethanol, very polar solvents. Then we get into solvents like dimethyl sulfoxide, which we abbreviate DMSO, acetonitrile, DMF, nitromethane. These have very high dielectric constants, but if you notice on the far right hand side the description of them, water, formic acid, and alcohols all have hydrogen that can form hydrogen bonding, and therefore these are called polar protic solvents. But solvents like DMSO, DMF, acetonitrile are still very polar. As a matter of fact, DMSO has a dielectric constant of 47, so it is more polar than methanol. It's more polar than ethanol. Um, but it doesn't have hydrogen bonding, and therefore we call that aprotic, an aprotic solvent, right? So that's a type of classification of polar solvents. Obviously, nonpolar solvents tend to be things like um, alkanes, um, ethers, larger ethers are fairly nonpolar, although diethyl ether is somewhat polar. THF, tetrahydrofuran, is a cyclic ether. It's polar. As a matter of fact, it's miscible in water. So, um, uh, we have to understand most of the reactions that are going to be occurring in these polar solvents. And the other thing that we have to kind of review is that like dissolves like, right? So generally speaking, salts, and if we make a salt, then the salts are going to be soluble in water. But I want to show you a little trend, and this is something that I think students tend to miss out on. they see that we have, maybe they're looking at some compound and it's a salt, and so they say, oh, it's going to be soluble in everything, or in polar solvents. It's going to be soluble in water. Well, let's take a look at sodium chloride. Obviously, we know sodium chloride is soluble in water, right? How soluble in water? Well, I can dissolve about 360 grams in a liter of water. That's pretty soluble. And if I compare it to something like ammonium chloride isn't as polar. So the NH4 is a polyprotic cation. It has some it has some um, covalent bonding to it, and therefore it's not as polar as something like sodium chloride. And you see that in its solubility, right? It's only soluble in water, well, 280 grams. Still, a lot can dissolve in water, but now what happens if I take the hydrogens off and I replace them with alkyl groups like butyl groups? So here I have tert-butyl ammonium chloride. Still a salt, right? Still soluble in water, but the amount that will dissolve decreases drastically to 20 grams per liter. So one of the important take-homes from this is that you have to look at a molecule in its entirety to really describe it. It may have a polar feature, it may have some nonpolar features, and that's what we weigh. We weigh polar features and we weigh nonpolar features, and we try to find solvents that can blend the two together. So as you add nonpolar groups, the solubility is going to decrease in polar solvents, but it's going to increase in nonpolar solvents. And that's an important concept to understand, that when we have a compound and it has a nonpolar part of the molecule, then we might want to start thinking about solvents that are less polar um, to try to dissolve it, right? So hopefully that kind of gives you a little bit more insight into thinking about what solvents are going to dissolve certain alkane derivatives.